So hello, this is real-timey patterns with CouchDB. My name is Alex. I'm the guy in the corner. I'm more of a front-end person at Neighbourhoodie, so that's where my focus is going to be. I would like to show a couple of things you can do with changes feed. And these couple of things are basically real-time front-end UIs and reactive backends. What that is, we'll get to in a minute. But first off, what's the changes feed? So very briefly, it is a by sequence index of document changes in a database. So CouchDB has two primary indexes. The first one is the by ID index. We're going to look at these two in a bit as well. And it's kind of what you would expect from a database. It indexes documents by their ID. But CouchDB is noteworthy because it also has a by sequence index, which holds all of the changes that happen in a database in order. And this is the underlying thing and what makes CouchDB so good at syncing and replication. But you can also use it yourself. You can perform normal GET requests against it. It's just an HTTP endpoint. You can perform long poll requests against it. You can open permanent connections to it. You can use queries and filter functions on it to just get the changes you're actually interested in. And most importantly, you can specify at which point you kind of want to jump in to the timeline, from which sequence number you want to start. And you don't need to learn sockets or third-party APIs or something that's been glued onto your database in hindsight, because the changes feed is, as I said, this absolutely integral part of CouchDB. And as all things CouchDB, it speaks HTTP and JSON and requires no additional tooling or knowledge. Well, knowledge, yes, but you know what I mean. You don't need to learn a completely new thing. So to demonstrate what you can do with this, let's have a demo, because that's always fun. We're doing a simple multi-user sketchpad. It uses React and a React library that allows me to sketch things. And that's it. It has a couple of features. Oh no, I have to manage too many windows at once. Sorry. Let's go back here. So what you can do is you can, of course, if you are a client of this URL, which is currently only one, you can draw things and your drawing appears for all the other clients. So you can draw anywhere and it will show up basically instantly. And that's pretty cool. I'm also going to try doing this on my phone right now. Let's see if that works. Oop. Let's give this guy a bad set of teeth. There we go. That was from my phone. Wonderful. So that clearly works. It's real time enough to be convincing. If you come to this sketchpad late, let's simulate this. You'll of course also get the changes and then can just keep going. What you can also do is you can go offline and it'll still work for the exact same reason it worked when you refresh. So let's simulate this really briefly. Let's go offline. With this one, skip back over here, give this guy some hair, whoop. And when I go online again, that'll just magically appear, which is cool. So yeah, this is fairly robust. Yeah, pretty nice. So let's talk about what makes this work. So it's about 100 lines of React, give or take a few helpers to make it look nice. We'll look at that in a second. The more interesting thing is, like, what does the data need to look like so this works? So what do you need to do in terms of a data model? Am I using some transactional or event-based schema? Does it work like a ledger? Am I possibly doing horrible date-based comparisons to figure out what goes where and who did what? In short, what does my data look like? Let's take a look, because I honestly don't know. I don't need to. I don't know because not because I'm negligent or lazy, but simply because it doesn't matter. So these are all of the strokes we've drawn. So there should be 7 of them. Let's check. 1, 2, 3, 4, 5, 6, 7. They're all here in the database. They have an ID that they got given. It doesn't mean anything in this case. And they contain some JSON, which I've never seen before. This is a lie. I obviously practiced this talk, but while developing this, I didn't need to look at this. This is just what comes out of the sketchpad. So how did it get here and how does it get back out? Let's look at that. First of all, how does it get in? The sketchpad emits an event on stroke. We get the stroke JSON in the event, and we just do a post request to our database URL, stringify the JSON that we get. We don't add anything, we don't mutate anything, we don't even look at it. We just throw it into the CouchDB. Goodbye, off you go. Yeah, that's it. So that's always nice about having a document-based database. You don't really need to care in advance what the data looks like. But how does it get back? And this is the interesting part. What you need to do to consume the changes feed is basically a GET request against the database URL +/_changes, and then you can provide a bunch of options. And what we're doing here is include docs true, which you might know from various other CouchDB APIs, which just gives us the entire documents. The type of, or the manner in which we're consuming it, in this case long poll, which means this connection will stay open either until something gets returned or until the timeout or the connection times out, in which case it's our responsibility to restart this request. And the magic is really in here, which is the since parameter, and this is what I mentioned earlier, what gives you the ability to jump into the changes feed at any given point in the timeline. So let's look at what the changes feed looks like. So this is more or less a representation of the by ID index, all of the documents by their ID, and the changes feed is over here. And there's a lot more in here because I've deleted a bunch of things in the past. But in essence, what happens is that every change is in here and it has an incrementing sequence number. And the sequence number with the hash is what you provide to the since parameter. So if you've already seen everything to 189, you can provide the since 189 and all of this. And then you will get everything from this point onwards. And that's really nice because, as I said, my documents do not care about any of this. I have to do absolutely nothing in order to make this work. So that's pretty cool in my opinion. That's very little code and very little fuss. Everything else in here is a bit of, housekeeping, making it look nice. I'm keeping track of the strokes made on this client so I don't draw them twice. Strictly speaking, I could probably omit that. It doesn't really do that much, but it's something you need to be aware of. You probably, depending on what your content is, you probably do care whether it originated on this client or not. There are various ways of solving this. This is one with the least overhead in my opinion. If you wanted to make this truly offline first, so you can also draw while you're offline, you would plug in PouchDB into the client, have that continuously replicate, or just replicate in some form with the CouchDB, and then you would point the changes feed to the local PouchDB, which you can also do. Yeah, so that's cool. Let's see what else we can do. So we can do something I call backwards backends. So traditionally you would do the front end. Ooh, that's not what I want. The front end talks to the back end, and the back end talks to the database, and the database and the front end never talk to each other, basically. You can do something different with CouchDB. As you just saw, we're having the front end talk directly to the database on the server. So this is a server URL, and we're talking directly to the database. You can do this because CouchDB is an HTTP server, and it provides user management and authentication, and it also provides role-based access management. So you can go quite a fair way into the development of an application without writing any server code. So why would you want to have this kind of backend that isn't between the front end and the database, but kind of just attached to the database? It's useful for very front-end heavy or even offline first apps where most or all of the user-facing business logic is handled by the front end and the database. But there might still be things you need to do that can only be done by the server. And one nice way to do this is having a small backend service, like the small node thing that runs somewhere, that listens to the changes feed from CouchDB and basically reacts to this. So what could it do? It could, for example, well, mainly react to data changes. Since the data doesn't flow through the backend still needs some way of knowing when it needs to do things, and the changes feed is great for this. And then you can query or filter the changes feed and see, okay, I need to send an email, I need to send notifications, I need to mutate data or update permissions or talk to third-party APIs. And all of that can happen in a nicely decoupled manner. And this is a nice way of doing it with the changes feed because the updates are near instant. You don't have to faff around with cron jobs and stuff like that. You don't need to manage the sequencing of updates yourself in your data model or in some other way, shape, or form. There's no ambiguity about the order of execution or the order of how things happened. And most of all, which is possibly tempting for people who haven't made this mistake before, is trying to handle this with dates and deltas between timestamps. The nice thing about the changes feed is that there is no date math. So you can never shoot yourself in the foot that way. Yeah, so in short, don't forget about the changes feed. It's kind of I feel it's sometimes a bit overlooked. It's great for a lot of things, like, as we saw, flexible, low-effort, real-timey or auto-updating UIs. And here's why we say real-timey, because strictly speaking, it's not real-time, and you can decide how real-time-ish you would like to have it. So you can have the connection to the changes feed always open, or you can just pull it occasionally. It doesn't really care how you consume it in the end. It's up to you. And you can build nicely decoupled and reactive backends with a fairly minimal overhead. That being said, real-time anything on the web has a cost, and this approach, of course, has its limits. So this likely won't be enough when real-time at a large scale is like the unique selling point of your software. But within sensible scopes, I feel it's really useful. And as I said, you can ease off on the real-timiness to reduce the performance impact. So it fits what you can, well, afford, basically. Let's put it that way. Yeah, I think that was it from my side. Does anyone have any questions? Let me switch back over to and hide this ugly mug here. LightFM asks, what's the best approach when using per user DB's global changes or many open connections to individual changes? You probably at some point will run into trouble with many open connections to individual changes feeds. That being said, if you have per user DBs, the global changes won't really help you that much because, yeah, I guess you want them per user. If I recall correctly, there was a way of pooling these and pulling them back apart again by having an intermediate service. I think Spiegel can do this, correct me if I'm wrong, Jan, which is a tool for dealing with the fact that eventually you'll run into issues with many parallel connections. My best approach when using this would be building things that don't require everyone to have this on at all times. That's probably what I do. If you need something where everyone is always connected to the changes feeds, that might get a bit tricky depending on how many users you have and how real time the whole thing has to be. If I had many users, I would try and back off the real timiness and not leave the connections open with long polling, but just poll occasionally. Radu asks, is it reasonable as a network request to ping a changes feed from a mobile app? Yes, sure. Again, it depends on how fast you need it to be, but it's entirely plausible. It's just a GET request like any other in that sense. Oh, I forgot OmniSync, of course, Jan. Sorry, and Spiegel is also quite old. So yeah, OmniSync is the thing. Jan can probably link that in a second. Thanks for reminding me. C. Borgold to ask, Jan is faster than me. Yes, we did build this in a yeah, as you said, I'll just explain it briefly. There's a fairly big application for vaccination centers where every vaccination center was connected to a central CouchDB with a real-timey approach. So this was nice because the users were basically buildings and there was a fixed number of them. But yeah, it's entirely possible. Yeah, as I said, this of course won't scale infinitely. At some point, you'll have to throw inordinate amounts of money at it. But for fixed sizes of things, this will definitely work. Yeah. So if you're, for example, if you know how many users you have for a given company, or how many employees a company has, or how many offices or points of sales, that kind of thing there are, then this is very plausible to use in yeah, commercial production settings. But yeah, if you have more detailed questions, please get in touch with us. We can very likely help. Thank you for listening, and thank you for all the thanks. All right, that was it from me.